Okay, so today we are going to start chapter 5. So we're going to look at 5.1. 5.1 is dealing with exponents. So we're going to look at all the rules that exponents have. They're going to seem overwhelming at first, but they're really not that bad. Just understand one at a time. Okay, I'm going to show you all of them today. All right, so first we're going to talk about evaluating exponential expressions. We already did this earlier in the semester, so this part will be a review. So remember that an exponent, all right, I don't know why, okay, there we go. I don't know why it does that. All right, so we got a pen, let's get skinny, and purple ink sounds good. Okay, so exponents that are natural numbers are shorthand notation for repeating factors. Remember, we talked about this is the base, and then this is your exponent. So what 3 to the 4th means is 3 times 3 times 3 times 3. So the exponent is how many times you're going to write the base. So if we had 7 to the 3rd power, that would be 7 times 7 times 7. So the exponent tells you how many times to write the base. All right, so let's evaluate these. So we've got 3 to the 4th power, which was in our example. So that means 3 times 3 times 3 times 3. Well, when you have a number to an exponent, please always make sure you reduce. So for example, 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So you would want to make sure that you simplify it all the way through. So remember that first test when I put that question on there, it was like a number squared, and then it was a number squared with parentheses and one without. Don't forget those rules, okay? So remember, as long as the parentheses are there, then you have to do what's inside the parentheses. For example, -5 in parentheses squared means -5 times -5, and a negative times a negative is positive. Okay, and then if there's not parentheses, then that just means -6 times 6, which is -36. Okay, so if the negative sign is inside the parentheses, then you write the negative sign however many numbers the exponent is. And if it's not, then the negative sign is only once. This is going to be 2 times 4 cubed. So you're going to go 2 times 4, 2 times 4, 2 times 4. So then you multiply the 2's. So 2 times 4 is 8, 2 times 4 is 8, 2 times 4 is 8, 8 times 8 times 8, oops, is 512. So remember, always make sure that you take care of the numeric values. Now here we have 3 times 4 squared. Well, that's 3 times 16, because 4 squared is 16, which is 48. So don't forget just those basic rules when you're doing exponents. So now let's talk about what happens when we plug the numbers in. Okay, so remember, if we have 3x squared, but x is 5. So you replace x with what it is. So if x is 5, then replace x with 5. Now I have 3 times 5 squared. So that means 3 times 5 times 5, which is 3 times 25, which is 75. What about -2x squared if x is -1? And always make sure that when you have these negatives, that you put them in parentheses. So now I'm going to replace x with -1. So now I have -2 times -1 squared. So that means -2 times -1 times -1. So also remember at the beginning of the semester we talked about if you have an odd number of negatives, your answer will be negative. So now I'm going to have -2 times 1. because -1 times -1 is 1. And then -2 times 1 is -2. All right, so we're going to use our first rule, the product rule. So the product rule says if m and n are positive integers and a is a real number, then a to some exponent times a to some another exponent equals a to the sum of the exponents. So for example, if I have 3 squared times 3 to the 5th equals 3 to the 2 plus 5, because you want to add those exponents. Well, what is 2 plus 5? So that would be 3 to the 7th power. So make sure that you are adding your exponents. Okay, and then of course, since this is 3 to the 7th power, you would always simplify that, which would be 2,187. So anytime it's a numeric value, make sure that you take it all the way to the end. All right, so let's look at helpful hints. 3 to the 5th times 3 to the 7th is not 9 to the 12th. You don't multiply the bases and add the exponents. You simply only add the exponents, okay? You have to keep if it's 3 here and a 3 here, then it has to be a 3 when you're done, okay? You cannot change the base. So do not change the base. All right, so since 3 to the 5th times 3 to the 7th does not equal 9 to the 12th, then what basically, remember 3 to the 5th, you've got 5. So 1, 2, 3, 4, 5. And then here we'll have 7. So 1, 2, 3, 4, 5, 6, 7. Let's snag that one there. Slide those over. So we have 5 threes and 7 threes, so that makes 12 threes, not 9. All right, so let's look at some of our rules. So 3 squared times 3 to the 4th. So since we have same bases, then you're going to add your exponents. So that's going to be 3 to the 4 plus 2. Well, what is 4 plus 2? Well, that would be 6. So 3 to the 6th power is 729. All right, x to the 4th times x to the 5th. Since we have the same base, then you're going to add the exponents. 4 plus 5 is 9. And then you stop. So the only difference between stopping here and stopping here is that you can actually calculate this. You cannot calculate x to the 9th if you do not know what x is. Okay, here we have z to the 3rd times z squared times z to the 5th. Look at the bases. They're all the same. So then you add the exponents. 3 plus 2 plus 5 is 10. All right, here we go. So here, when you're multiplying these, just like we multiplied all of these, you still follow your basic rules. So I have 3y squared times, because remember, when you have parentheses, it just means you're multiplying, so this is really times. So now I have -4y to the 4th. So break it apart. 3 times y squared times -4 times y to the 4th. Now group things that are similar. So I have 3 and -4, so 3 times -4, and then group your y's. Y squared times y to the 4th. Well, what is 3 times -4? Well, it's -12. What's 2 plus 4? That's 6. So that would be y to the 6th. So your final answer is -12, y to the 6th. So looking up here, 3 times -4 is -12. Y squared times y to the 4th, so 2 plus 4 is 6. So that is how you can look at it, okay? Don't forget that if there is no exponent, then it's just 1. So if you see x, it's the same thing as x to the 1. But also remember that x is also equal to 1x. So x is equal to 1, x to the 1. So the 1s are assumed, okay? The 1s are assumed if there's nothing there. If there's a 0, then they'll put 0. All right, so we're going to use the product rule. So here we have 6x cubed times negative 2x to the 9th. So break it apart. 6 times x cubed times negative 2x to the 9th. Multiply 6 times negative 2, x cubed times x to the 9. As long as these bases are the same, you're good to go. So 6 times negative 2 is negative 12. 3 plus 9 is also 12. So your final answer, negative 12, x to the 12th. Okay, here you're going to group your like terms. So m to the 5th times m. And remember, that's really assumed to have a 1 there. And then group your n's, n to the 10th, n to the 8th. So now that you have your like bases together, then you're just going to add your exponents. So you're going to have m to the 6th, n to the 18th. Okay. So also don't forget here, let me change this color. I don't know why it's giving me so many options. All right, so this is really a negative 1 right here. So we're going to group negative 1 and 4. We're going to group the x's, and then we're going to group the y's. And also remember, this is y to the 1. So now you've got negative 1 times 4, which is negative 4. 9 plus 2 is 11. 1 plus 11 is 12. Final answer, negative 4, x to the 11th, y to the 12th power. All right, so now let's use the power rule. So now the power rule says if m and n are positive integers and a is a real number, then, okay, so your exponents, so now we went from a to the m times a to the n equals a to the m plus n. So we went from this rule to what happens when we raise a power to a power, which is why they call it the power rule. Okay, so now a to the m to the n. Now you're going to multiply your exponents. For example, if I have 3 squared to the 3rd power, okay, so that means 3 to the 6th power, which we would put in our calculators and get the actual numeric value, which would be 729. Okay, so if the bases are separated, then you add your exponents. If there's one base, power to power, you multiply. Because what this is saying, just to verify this, okay, so this would be if I had 2 to the 3rd power squared. That means 2 to the 3rd power times 2 to the 3rd power, because you're doing it twice. Now you would add your exponents, because that would be 2 to the 6th. So see how easy it is to just multiply them instead of rewriting it. Okay? So 2 to the 3rd to the 3rd. So 2 to the 3rd times, so 2 to the 3 times 3. Well, what is 3 times 3? That would be 9. What is 2 to the 9th power? That would be 512. Always make sure that you carry it all the way through. X to the 4th squared. Well, what's 4 times 2? X to the 8th. And as long as this is a variable and you do not have a value, then you stop right there. All right, so now we're going to use the power rules for products and quotients. So for multiplication and division. Okay, so if n is a positive integer and a and b are real numbers, then, so if I have two numbers that are going to be multiplied together, raised to an exponent, then you basically just distribute that exponent to each piece. So a to the n times b to the n. See, now their bases are different. So you don't add the exponents because the bases are different. Okay, so for example, here's kind of a long one. 5x squared y to the third power. So you're going to distribute that exponent back. So 5 to the third power. And now I have x squared to the third power. And then I have y to the third power. So 5 to the third power is 125. These you have to multiply them because it's the power to the power. So that's to the sixth and y to the third. All right, let's see here. So if we're going to exemplify this, then we're going to have to take this exponent, distribute it to each piece. So x to the 7, y to the 7. Okay, some of them are just going to be this simple. Don't overcomplicate them. Just accept the rules, okay? So here I'm going to have to distribute the 4. So 3 to the 4th, y to the 4th. Well, 3 to the 4th is 81. Y to the 4th stays y to the 4th. Okay, even if it's really long like this, you still are going to distribute that exponent to every single piece. So -5 squared, x cubed squared, y squared squared, c to the 4th squared. So now, -5 squared, this just means -5 times -5. So that's going to be a positive 25. Multiply these two because it's a power to a power, so that's x to the 6th. Multiply 2 times 2, so that's y to the 4th. And 4 times 2 is z to the 8th power. Okay, so here we've got negative xy 4th to the 6th power. So you're going to distribute this and this. So you're going to have -1 xy to the 4th power raised to the 6th power. Okay, because don't forget, there's that imaginary 1 right there. So now I've got -1 to the 6th power, x to the 6th power, y to the 4th to the 6th power. So -1 to the 6th power, well, remember we have an even, 6 is an even number of negative signs, so that 1 is going to just be positive. X to the 6th, and then multiply power to power, so that's 24. So remember, there is that assumed 1 right there. Okay, it's just assumed, so you don't really have to put it in your final answer. All right, so what happens, the power of a quotient? Okay, so now if I have a division problem raised to a power, you're still going to distribute that exponent to both pieces. So it's going to be a to the n over c to the n. C cannot be 0 because you cannot have 0 in the bottom. So an example of what that would look like is if I had p over 4 to the 4th power, then that would be to p to the 4 over 4 to the 4, because you would need to distribute that 4 to both pieces. And then, of course, you would want to finish this problem, p to the 4th over 4 raised to the 4th power is 256. And that would be your final answer. So r over s to the 6th is going to be r to the 6th over s to the 6th, because you're simply going to distribute the exponent to both parts, just like if it were multiplying. 2x to the 4th over 3y to the 5th to the 4th power. So you're going to take an share that exponent with every piece. It gets shared with the 2, it gets shared with this, it gets shared with the 3, it gets shared with this. So 2 to the 4th, x to the 4th fourth, over 3 to the 4th, y to the 5th fourth. So power to a power, you multiply. Power to a power, you multiply. So 2 to the 4 is 16. 4 times 4 is also 16. 3 to the 4 is 81. 5 times 4 is 20. So your final answer, 16x to the 16, 81 over y to the 20. Using the quotient rule and defining the zero exponents. Okay, zero exponents are pretty cool. If m and n are positive integers and a is a real number, then a to the m divided by a to the n. So remember when we were multiplying them, if I had a to the m times a to the n, then we added. So this was a to the m plus n. Well, when you are dividing, as long as the bases are the same, then this time you're going to subtract. So if you're dividing, you're going to subtract. So you're just going to take the two exponents and subtract them from one another. So for example, if I have x to the 7 divided by x to the 3rd, since I'm dividing like bases, then I'm going to subtract their exponents. 7 minus 3 is 4. So basically you're taking and subtracting 3. This one goes away. 7 minus 3 is to the 4. All right, so this is the exact same example they just gave us on the front. So now if I have negative 2 to the 14 divided by negative 2 to the 10, well, negative 2 is the same, so we're going to keep our base. So now take your 10 and subtract it up. So this one goes away because 10 minus 10 is 0. So 14 minus 10 is 4. So that would mean negative 2 times negative 2 times negative 2 times negative 2. So 4 negatives make a positive, and 2 to the 4th power is 16. Okay, so here what you're going to do is we have numbers, A's and B's. Group them separately to help your eyes make it make sense. So you're going to group. Okay, 9 over 3, a to the 4th over a, b to the 7 over b squared. So now what is 9 divided by 3? Well, 9 divided by 3 is 3. So remember, this is technically a 1. So what we're going to do is you're going to subtract that 1 from both pieces. So that one goes away, and now you're left with a to the 4 minus 1. And then you're going to subtract this 2 from both of these. So that one's gone now. Now I have 7 minus 2. So a to the 4 minus 1 is 3, and b to the 7 minus 2 is 5. So we got 3, a cubed, b to the 5th power. All right, we're almost done. We only have a few more slides. All right, now if a to the 0, if you have a number to the 0 power, any number, okay, any number, it's always going to equal 1, as long as a is not 0. 0 to the 0 is undefined. It doesn't, 0 to the 0, it's just 0. It's just nothing. It's undefined. Okay, so if I have any number raised to 1, okay, so for example, or any number raised to 0, I'm sorry, it equals 1. So if I have 5 to the 0 power, it equals 1. If I have 1 million to the 0 power, it just equals 1. So no matter what you have to this, as long as it's to the 0 power, it will always be 1. There's no math to be done. It's just equal to 1. 5 to the 0, 1. X, Y, Z cubed to the 0 power. Well, if you distribute that 0 to all the parts, then x to the 0 is 1. Y to the 0 is 1. Z cubed to the 0 is 1. So 1 times 1 times 1 is 1. So because this whole thing is to the 0 power, it's just equal to 1. You technically didn't have to do all that. Negative x to the 0 power, well, this piece right here is equal to 1. Okay, so you have negative 1 times x to the 0, which is just negative 1. Okay, the negative sign is not attached to this exponent, so you need to make sure that you keep the exponent throughout the problem. Okay, now deciding which rule to use. All right, so since I am dividing like bases, then we're going to subtract. Okay, so you're going to subtract that 4 from both parts. Here I have a power to a power, so I'm going to distribute the exponent to all of the pieces. 3 to the 4th times y to the 4th to the 4th. So 3 to the 4th is 81. 4 times 4 is 16. And here I'm dividing and using an exponent, so I'm going to distribute. So x cubed over 4 cubed, so x cubed over 64. Because 4 times 4 times 4 is 64. Okay, here I have 4 to the 4 minus 4 to the 0. Well, 4 to the 4 is 256. 4 to the 0 is 1. 256 minus 1 is 255. You do not add or subtract your exponents here because you're subtracting the numbers. You only add the exponents when you're multiplying the bases, so be very careful. X to the 0 to the 5th power plus 3 to the 0 to the 6th power. Remember, anything to the 0 is 1. So that's 1 to the 5th plus 1 to the 6th. Well, 1 to any power is 1. So 1 plus 1 is 2. So this craziness right here is just equal to 2. Okay, here we're going to distribute. As long as you have parentheses raised to a power, you're going to use that power rule and distribute it out. The bottom, you're not going to have to do anything with because it's already simplified until you get the top done. So distribute that 3 to all the parts. And then 3 times 3 is 9, 4 times 3 is 12. So now I look at this and break it into pieces like we did a second ago, okay? You have 8 over negative 8. Oops, there we go. And then we have a to the 9 over a to the 9. Oops, times, I'm so sorry, b to the 12 over b to the 2. So 8 divided by negative 8 is negative 1. And then if I subtract this 9 from this 9, the a's are going to go away altogether. So this is just going to cancel out because 9 minus 9, just kind of break this apart, that would be a to the 0, and a to the 0 is 1. So this is going to become 1. So now negative 1 times 1 times b to the 12th minus 2. Goodness gracious, what am I going to do with this little box? Okay. So negative 1 b to the 10, or just negative b to the 10. All right, I am very sorry. All right. And that is our last example. So make sure that you attend our Zoom chat on Tuesday at 7.